Assalamu alaikum, students. Today we start the second type of titration, that is precipitation titration. We perform this type of titration when our analyte that's form insoluble or a stable precipitate with titrant, and the titrant here we use that is also a precipitating agent. So when our analytes has a property that it forms an insoluble material, then we can perform this precipitation titration as a quantitative analysis. And in this PowerPoint presentation, what is the definition of this? That a special type of titrometric procedures involves the formation of precipitates during the course of titration. The titrant react with the analyte, forming an insoluble material, and the titration continues till the very last amount of the analyte is consumed. The first drop of the titrant in excess will react with an indicator resulting a color change and announcing the termination of the titration. Basically, this is the principle of that titration, that is the analytes that completely converts into a form of insoluble precipitate, and we can easily quantify the substance by this precipitation titration. Okay, then we have, this is the basic principle. Then quantitative precipitation can be used for the volumetric determinations, and silver nitrate react with sodium chlorides, converts into a insoluble precipitate, that is AgCl. AgCl, that is our desired precipitate for the quantification of chloride. So the titration involved, the precipitations are called precipitation titration. Involves the precipitation, that is called the precipitation titration. Here we have two different type of titration, direct or indirect. And we know that, as we discussed earlier, when it's fulfill all the conditions required for the direct titration, then we perform the direct titration, that is a rapid reaction and a stable precipitate is formed between analyte and that of titrant, and a suitable indicator is available, then we perform the direct titration. And indirect titration, when we perform when a suitable indicator is not available, the reaction is slow. And here, that is another important property that is also involved here, that is the solubility constant of the precipitate. The stability of the silver chloride or the stability of analyte precipitate, depending upon this stability of this precipitate, we also perform this indirect type of titration. Okay, reaction must satisfy this condition. Precipitate must be practically insoluble. If it is soluble, then we can't find out the end point. Precipitation must be rapid one. A rapid reaction is required. Possible to detect the equivalent point by the help of the different indicator. Method based on precipitation of insoluble silver is known as argentometry. It means that when we using the silver as a titrant, the type of the titration, that is called the argentometry. Why we call it argentometry? Because the silver in Latin, it is called the argentum, and so on the basis of the name of the silver, it is called the argentometry. And what is the basic definition of this argentometry? That is the, we can see that in that the titrations involving the estimation of the ions by precipitation with a standard solution of silver nitrate is known as argentometry. metery, यानी कि जब हमारे पास titrant that is used as in the form of silver nitrate, the type of the precipitation titration is called the argentometric titration. And then similarly, if we use the mercury for the detection of iodine or the detection of bromide or iodide, then the type of the titration that is called the mercurymetry. Okay, in which or we can see that the titration involving the estimation of the ion by precipitation with a standard mercuric nitrate solution, then it is called the mercurymetry. Okay, when we use the silver nitrate, then it is called the argentometry, and when we use the when we use the mercuric nitrate, then it is called the mercurometry. So depending upon the name of the titrant, we have different type of precipitation methods. Now the solubility product that is very important here, that is we need a insoluble complex of silver chloride. Okay, we need a very insoluble form or the stable complex of silver chloride. And how it is stable? At that particular pH, at that particular temperature, at that particular reaction condition, that's depend upon the number of the things that is silver chloride that is present in undissolved solid form. And that is also a dissolved but undissociated form molecule that is present into the solution. It is present into the solution, and that is also present in the solution that is the ionized form or the dissolved or the dissociated ions of silver and chloride. So depending upon the concentration of this ionic form of silver chloride, silver in the chloride, and also the secondly that is the undissolved form of this solids, the concentration of this AgCl that is depend upon both of these two things, that is undissolved and dissolved dissociated form of silver chloride. ठीक है, हमारे यहाँ पर इसकी फॉर्मेशन जो है किस डायरेक्शन में मूव करेगी, that is depend upon the undissociated and dissociated form of the silver chloride. The overall equilibrium is that is silver chloride in the solution, that is depends upon the concentration of silver and chloride ion. And basically that is totally different upon the silver, यानी कि जो solubility constant है, that is specific solubility constant that is totally depends upon this concentration of the silver or the chloride ion that is present in the solution. Okay, it is not okay, it is not concerned here. Okay, we directly reach to that effect of acid upon the solubility of precipitate. Effect of temperature, we must discuss here that effect of temperature, we know that by increasing the temperature, the solubility of a small precipitate will also be increases. By increasing the temperature, the solubility of a small precipitate will also be increases. Here you have an example, the solubility of the silver chloride at 10 degrees centigrade and 100 degrees centigrade is 1.72 milligram and 21.1 milligram respectively. By increasing the temperature, its solubility will also be increases. ठीक है, हमारे पास क्या है कि by increasing the temperature, solubility will also be increases. Effect of solvent upon the solubility of the precipitate, depending upon the solvent in which we are making the precipitate, or effect in which we are precipitate, or the use of solvent that is used for the washing of the precipitate, the solvent also affect the solubility, because as we know that the organic compounds are soluble in organic solvents. Like here, the solubility of the most of the inorganic compound is reduced by the addition of the organic solvent, such as methane, methanol, propanol, and acetone. See, depending upon the solvent in which the precipitate is formed, it is very important type or the choose of the solvent in which we wants to prepare the our precipitate. We know that it's like dissolve like, and we know that acid is insoluble in acid and base are insoluble in basic solution. We have three different types of precipitation titration, or basically here we discuss the three different type of argentometric type of titration, in which we use the silver nitrate as a titrant, Mohr's method, Volhard's methods, and Fajan's method. These methods are based on the name of their inventors, Mohr's, Volhard's, and Fajan's methods. Now first discuss about the Mohr's methods. And this Mohr's method, basically we want to find out the concentration of different halides, chloride, bromide, iodide, and the pseudo halides. What are the pseudo halides? Pseudo halides that also contains a negative charge. Their oxidation state is also that contains a single negative charge. So cyanides and thiocyanides can also be quantified with the help of these Mohr's, Fajan's, or Volhard's method, or we can say that with the help of this precipitation titration, we can find out the concentration of halides and pseudo halides. Halides हमारे पास कौन से हैं? That is chloride, bromide, and iodide. And what are the pseudo halides? Pseudo halides we have thiocyanide or cyanide. So quantitatively we can find out the concentration of these substances, quantity of these substances by using this method. Now, what is this Mohr's method? As such, we discussed that all of these three methods that is different in their methods and also in their type of indicator we use. Now, let's first start with that of the Mohr's method, that is the determination of halides. Chloride with silver nitrate using potassium chromate solution as an indicator. अच्छा, यहाँ पे बेसिकली दिस मैथड इसको जो डिस्क्राइब किया है वो उन्होंने कि जस्ट वी आर गोइंग टू फाइंड आउट द कंसंट्रेशन ऑफ दिस क्लोराइड विद द हेल्प ऑफ सिल्वर नाइट्रेट using potassium chromate solution as an indicator. So first thing, what is our analyte? Our analyte is a chloride ion. What is our titrant? That is of known solution, or the known standard solution is silver nitrate. And which is our indicator? Our indicator is potassium chromate. Okay, so three different things we have. We have analyte, we have our titrant, we have our indicator. Now, what is the method? Is that it is a direct method. It is direct method of the determination of chloride ion. So it means that your titrant, that is silver nitrate, that is present in the burette. Your analyte, that is chloride, that is present in your conical flask, and along with that of potassium chromate, that is the indicator. And it is mostly useful for the estimation of the chloride. And the simple reaction, we know that the silver react with that of chloride and convert into AgCl, that is a stable one, and precipitated silver chromate. So we have two different type of the precipitate will form. First, when all of this chloride that is consumed by means of the silver, the next drop of the silver then react with the chromate ion that is present as an indicator and convert into the silver chromate. So one thing that is very important, choice of your indicator, because we know that the whole reaction that is based on solubility constant. So here the silver chromate that forms a precipitate that is not as stable as compared to that of silver chloride. Silver chloride as more stable one. Silver have more affinity towards the chloride ion as compared to that of chromate ion. So this precipitate that is formed initially via the addition of the silver, that is not a stable one. So when all of the silver that is utilized by chloride ion ion, the next drop of then there is no chloride, then the silver then form a complex or the precipitate with that of the chromate ion. ठीक है, precipitated silver chromate through sparingly soluble in water is more soluble than silver chloride, and then the red color due to the silver chromate does not appear until all the chloride has been precipitated as silver chloride. When you add that, you observe that a red color is formed, but when you shake the flask, then the color will disappear. Why the color will disappear? Because when first silver reaches to that of the chromate, it form a complex, but the complex is a very unstable one. And when a complex is a very unstable one, when we shake that one, then the silver that form a complex, instead of chromate, it releases the chromate and form a complex with that of a chloride ions. When whole of the chloride ion is consumed, then after that the silver then form a chromate, and you appears a red, the brick red color due to the formation of silver chromate. That shows that all of the chloride that is consumed and shows the end point. That is the reaction. That is silver nitrate. That is a possibility to react with that of chromate and convert into the silver chromate, that is red precipitate. The sensitivity of the indicator depends upon the concentration, temperature, acidic or hydrogen ion concentration, concentration of electrolyte, and manner of observing the red coloration. Okay. To find out the endpoint, it is very important through when we perform this one. So the method that is developed method, that is very important one, that is to avoid any error in the quantification. One thing that is very important to indicate indicator that indicates the endpoint that is very close to that of an equivalence point. You know, this thing that is dependent upon the concentration of the indicator and the temperature that is involved throughout the reaction. Hydrogen ion concentration, that is the ionic condition. Why the hydrogen ion is necessary, we discuss later it here. And the concentration of the electrolyte and the manner of observing the red coloration, that is your observation. Depending upon your observation, it is very important for the quantitative analysis. ठीक है. This method utilizes the chromate ion as an indicator. Chromate forms a precipitate with silver, but this precipitate has greater solubility than that of silver, as we discussed earlier. Therefore, silver chloride is formed first, and after all chloride is consumed, the first drop of silver excess will react with the chromate indicator, giving a reddish precipitate of silver chromate. ठीक है. Now the precaution that is very important here. What is the precaution here we take in Mohr's method? That is very important here. That is the titration must be done in neutral or slightly faintly alkaline media. What the alkaline media के अंदर हमें ये perform करना है? Why? This method we need a very neutral media. Neutral medium should be used. The pH must be nearly to that of a 7, nearly to that of a 7 or 8, not a higher alkaline solution. We need to be used, and neutral medium should be used, since in alkaline solution, if we use the alkaline solution, silver will react with hydroxide ion and forming the silver hydroxide. We know that all the matters are electropositive in nature. When these electromatters that is present in water or a higher alkaline pH, the possibility is that these matter will convert into the hydroxide, and this hydroxide that is a very stable one. So the silver, it is not available for the reaction for forming the precipitate. So avoid this. We don't need an alkaline solution, we need a neutral one. So maintain the pH towards the alkaline, towards the neutral one. If it is alkaline one, then the chances of that the metal is converts into the metal hydroxide, first thing. And the second one, if it is not the neutral one, it is an acidic media, then chromate will be converted into the dichromate. We need the chromate for the color change. We need the chromate ions in its original form. Okay. When it is the acidic media, then it will oxidize and it is converts into the dichromate when that is not required. So we can't find out the perfect endpoint in the presence of dichromate ion. Therefore, to maintain the pH of the solution, it is very necessary that it must be a neutral one nearly to that of a 7. There is always some error in this method because a dilute chromate solution is used due to the intense color of the indicator. This will require additional amount of the silver for the silver chromate to form. So we need some very dilute solution to avoid this type of color change or this type of error. One thing I also want to discuss it here, that is chlorides of metals like iron or aluminum or the zinc or zinc or tin. Okay, which hydrolyze to give an acidic solution, or the chloride of the metal sign like the nickel, cobalt or the copper, which gives a highly colored solution, cannot be titrated by this method. ठीक है, दो तरह के जो metallic ions हैं like the chloride if it is present in the form of ferric chloride or the aluminum chloride or the zinc chloride or tin chloride or the certain metals that gives a colored solutions like the nickel, copper and the nickel है, cobalt है या फिर copper है. We can't perform here due to the due to the because these metal ions that forms an intense color and that's hindered the end point. ठीक है, तो कुछ ऐसे मेटल आइंस हैं जो कि एसिडिक सॉल्यूशन प्रिपेयर करते हैं वो, और कुछ मेटल आइंस जो कि कलर्ड सॉल्यूशन फॉर्म कर रहे होते हैं उनको हम मोहर्स टाइट्रेशन के थ्रू क्वांटिफाई नहीं कर सकते. ठीक है, और रीजंस मैं आपको डिस्कस कर चुकी हूँ. ठीक है, limitation is also there, that is allowable pH range is 6.5 to 10, not higher than 10. Below pH 6 there is increase in the solubility of the silver chromate. Above pH endpoint जो है वो hydroxides बन जाएंगे. If the solution is alkaline, make it acidic with nitric acid, then neutralize it by adding the sodium bicarbonate. These are the different methods by which we can neutralize the different acidic or the alkaline solution and converts into the neutral one. And another limitation is that if appreciable amount of ammonium salts are present, the pH should not be exceed 7.2. ठीक है, ammonium salt that is used either in the form of the buffer or other thing, the pH not should be. In reverse titration, iodides and bromides cannot be titrated. What's means of reverse titration? Reverse titration means that basically here the precipitating agents that is present in the burette and it's is added into the chloride solution or in the halide solution, that is the direct titration. But we reverse these two things, that is in the solution of silver nitrate, if we add the sodium chloride and iodide or the bromide, then it produces the different error in the reaction. It is not possible. So the reverse titration is not possible in case of Mohr's method. These are the different method how we prepare the different solution. Leave it now. ठीक है, हम इसे डिस्कस नहीं कर रहे. Now we switch to that of another method, that is Volhard method. Now, what is this Volhard method? Basically, Volhard method, that is the indirect or the back titration. And you know that what is this back titration? हमें मालूम है कि back titration क्या होती है, जिसके अंदर your analyte, your titrant, and your indicator that is present in the same class के अंदर present होता है, and leftover volume of the titrant can be estimated with the help of the थर्ड रिएजेंट. और हम थर्ड रिएजेंट के थ्रू जो लेफ्ट ओवर वॉल्यूम है उसे हम मालूम करते हैं विद द हेल्प ऑफ थर्ड reagents. So what is this Volhard methods? This Volhard methods इन्होंने basically बता दिया है कि that is estimation of the is a method for the estimation of the silver ions in dilute acidic solution. Volhard designed the method of estimation of the silver ions. Basically, when where we need to estimation of silver ion when the excess of silver ion is present. Excess of silver ion, that is our titrate. In dilute acidic solution, by titrating against a standard thiocyanate solution, in the presence of ferric salt, ferric ammonium sulfate as an indicator, it has been extended to estimate the chloride, bromide and other several analysis. ठीक है, हम इसको step wise समझते हैं. The first thing is that our analyte is the halide one. ठीक है, our analyte is the halides one, either it is chloride, bromide and iodide. So excess amount of silver nitrate that is required to neutralize with that of a quantitative amount of chloride we add in your reaction flask along with that of indicator, and the indicator here we have that is the ferric ion in the form of ferric ammonium sulfate. So all of these things that is present into the reaction flask, what is present in the reaction flask? Your chloride, your halides, titrant, silver nitrate, and your indicator, that is the ferric one. All of these things that is present into the reaction flask. To the first, the precipitation is formed between titrant and analyte, and the silver chloride or the silver iodide or the silver bromide will form. When all of these halides will consume, then the leftover volume of the silver, because we add an excess amount of the silver, is leftover volume is quantified with the help of a third reagent that is present into the burette. The burette that also contain the thiocyanate. As we discussed earlier, the silver nitrate in the argentometry that is quantitatively react with halides or thiocyanate. So here we want to measure the leftover volume of the silver. So we take the thiocyanate, in the burette as a titrant, not as a titrant, is a third reagent to find out the leftover volume of silver. So the thiocyanate react with that of a leftover volume of the silver and convert into the silver thiocyanate. Then the two precipitate will form in this reaction flask. First one that is the AgCl and the second one that is AgSCN. So the two precipitate is there. So we must concern here the solubility constant of these two products, which one is the most stable one. So in the presence of amines, this AgCN, okay, let's discuss it here. Ammonium potassium thiazide solution is used in conjugation with 0.1 molar AgNA3 in the assay of the substance which react with nitrate but which cannot be determined by direct titration with silver nitrate solution we discussed earlier. ठीक है, हम इसे डिस्कस कर चुके हैं कौन सा सॉल्यूशन जो है हमने यहाँ पे यूज किया इन दिस मेथड टू द हैलाइड सॉल्यूशन a known excess of silver nitrate is titrated with 0.1 molar अमोनिया और पोटेशियम थायोसाइनेट, कोई सा भी थायोसाइनेट हो सकता है, अमोनिया भी और पोटेशियम थायोसाइनेट सॉल्यूशन is called the Volhard method. In this method, the precipitate of the silver chloride is filtered off. Why this filtered off? Because the because in this reaction flask, two precipitates are formed. One is thiocyanate, silver thiocyanate, and the second one silver chloride. Okay, and both of them that have the more or less the same stability constant. So in the presence of this thiocyanate, there is a chance that silver chloride precipitate will redissociate. So to protect it, we first filter this precipitate, and then we start the second type of to find out the leftover volume of thiocyanate with that of thiocyanate, leftover volume of silver with the help of thiocyanate. And not only the filtered off, the second method we can also use some masking agent then mask with that of a silver chloride, and we can easily perform the second titration to find out the leftover volume of silver. Okay, here we have discussed that filtered off and the filtrate is titrated with a standard thiocyanate solution using the ferric ammonium sulfate solution as an indicator to find out the reddish endpoint in the form of ferric thiocyanate. What is the overall reaction is there? Overall reaction is there, that is ammonium chloride, or the chloride is there, simply the chloride, it formed the silver chloride. When of the chloride that is consumed with that of a silver one, and the silver that is present in the excess amount, how we find out this excess amount of the silver, we use that ammonium thiocyanate or the thiocyanate. Thiocyanate react with that of a leftover volume of the silver and convert into the silver thiocyanate. Okay. And then after that, the whole of the sodium thiocyanate, the silver that is consumed by that of thiocyanate, the next drop of the cyanate ion react with that of a ferric ion and convert into the ferric thiocyanate, and the bricks red coloration is there. That is the whole of the reaction that is involved there. Okay, the two precipitates will form. So the first, when this reaction is completed after giving certain period of a time, when the precipitate is completely formed, we filtered it and removed the silver chloride from the solution, and then we performed the second process of titration with the help of thiocyanate in the same flask that formed the AgCN. Okay, that gives you the leftover volume of silver. Okay, this is an indirect method for chloride determination where an excess amount of standard Ag is added to the chloride solution containing ferric ion as an indicator. The excess silver is then titrated with the standard thiocyanate solution until a red color is obtained, which results from the reaction. ये red color यहाँ पे आएगा. It's a very clear one. The indicator system is very sensitive and usually good results are obtained. The medium should be acidic. In the first Mohr condition, the medium should be a neutral one. Here, where the medium should be an acidic one to avoid the formation of ferric hydroxide. We know that if an alkaline one, the ferric that can readily converts into the ferric hydroxide. ये मतलब आपका इंडिकेटर जो है वो precipitate out हो जाएगा and is not available to give the end point. ठीक है, first thing is that we need a acidic one. However, the use of acidic medium together with added thiocyanate titrant increases the solubility of the precipitates, leading to the significant error sometime into the acidic media. That is why we remove the AgCl from the reaction. Okay. This problem had been overcome by two main procedures. Yes, two main procedures कौन से हैं? First thing, the reason for removing the precipitate of the silver chloride react with thiocyanate to form the change in titer value. हमने पहले ही silver chloride को remove कर लिया वहाँ से. And second one, in determination of iodide and bromide, it is not needed because the reaction is negligible. It is only for that of a chloride ion. Chloride के अंदर दोनों की stability constant के अंदर तकरीबन एक ही जैसा है. That is why, but not with that of iodide or bromide. उसमें ज़रूरत नहीं है. Especially for chloride determination. In case of chloride, it is usual to filter, जो हम पहले भी बता चुके हैं. Or second thing, that we can also use a masking agent or coagulated by the precipitate by means of either dibutyl phthalate or nitrobenzene. यानी कि दो ऐसे chemical हैं that is also used as a masking agent. Nitrobenzene and dibutyl phthalate. ठीक है. ये दोनों compounds हैं that is also used as a masking agent if we are not using to filter it, so we can use this masking agent. The excess of silver nitrate is back titrated with potassium ammonium thiosulfate using ये हम discuss कर चुके हैं already. This is the precipitation one, and that is the type of how we made the solution of these compound and the procedure. Third method we have, that is the Fajan's method. Fajan's method here, basically we are going to use an adsorption indicator is used. Okay, every time when we use the indicator, there is some color change of the indicator, and that shows the end point by reacting with that of titrant. And what is the difference here in case of the Fajan's reaction? The indicator that is used as an adsorption indicator, basically when the precipitate is formed, these indicator in the last, it adsorbed on the outermost layer of the precipitate, and by adsorbing, it changes the color of precipitate. So the indicator in this condition causes or changes the color of the precipitate. Indicator will not change its own color. It changes the color of precipitate by the process of adsorption. By the process of adsorption. For example, we know that the precipitate we form, we have the silver chloride. On this precipitate, your indicator will absorb. And how this indicator is absorbed, there is a process by the process of adsorption. The important indicator mostly we use, that is the fluorescein and its derivatives. Fluorescein के जो derivatives होते हैं वो और fluorescein, that is mostly used as an adsorption indicator, and these derivatives are adsorbed to the surface of colloidal silver chloride. After all chloride is used, the first drop of the silver will react with fluorescein, forming a reddish color silver. ठीक है, हो क्या रहा है कि basically first thing is that is very important in case of this Fajan's method, that is your indicator must be present in an ionic form that contains a negative charge. We maintain the media in such a way in an acidic condition that your fluorescein indicator or indicator that is present in negative form. When silver chloride, all of these chloride that is consumed with that of a silver 1. And when we add silver 1 as a titrant, when all of these chloride is consumed and precipitate is formed in the form of silver chloride, and when we add the silver in the form of the titrant, the silver will present at the corner of this precipitate, that is present at the outer side of this precipitate in the form of Ag positive ions, in the form of Ag positive ions that is present on the surface of these precipitate. And this indicator that is also present into the anionic form due to this negative charge, it adsorbed at the surface of this precipitate because the outermost layer that contains the Ag positive, and this fluorescein that interact or attract toward this positive charge and converts into AgF. ठीक है, outermost के ऊपर ये absorb हो जाएगा, and by absorbing this, it will change the color of the silver chloride, that is a colorless, into a reddish color. Acha ji, the most important method we have the Volhard method. It is widely used because we can detect the endpoint of the precipitation titration very well. Acha, this precipitation titration, chances of error is there, because the color change that is very different as compared to that of other method of titration. Chances of error is there, because there is a chance of titration error. To avoid this, every time we can also perform the blank one. We can also perform the blank titration to avoid all of these type of errors. So we can easily identify that we can nullify the different error by performing the back titration. What is the limitation of precipitation titration? A few number of the ions such as halides ions can be titrated. This method is only for that of a halide ion. Co-precipitation may be occurred, maybe sometime if you are not maintain the reaction condition, then co-precipitation is very, and it is very difficult to find out the end point. Sometimes you have the colored precipitate, so endpoint that is very it's not very easy to indicate that. And these are the different condition of different titration. We already discussed it. the different conditions required for Volhard methods, ferric nitrate or the ferric ammonium sulfate. This is the repetition. That is the same thing we already discussed here. In case of Volhard method, that is we already discussed this type of the indicator. Here we use axis of silver. We already discussed it in Volhard method. It is necessary to prevent the reaction. ये भी हम discuss कर चुके हैं कि we use the nitrobenzenes और नाइट्रोबेंजीन एब्जॉर्प्शन इंडिकेटर भी हम यूज पढ़ चुके हैं कि equivalence point indicator is absorbed by the pressment using the different type of the colors, and these are called the absorption indicator. For example, fluorescein, eosine, or tetrazine and rhodamine. These are the different absorption indicator, and also we have discussed this. First you have the silver and the chloride that is initially it is present into the excess amount, and after this chloride that is consumed, then at the outermost layer silver is there, not the sodium, silver is there, and then it is converted into the react with that of a fluorescein ion. ठीक है, अच्छा जी, इसमें और क्या है? एब्जॉर्प्शन इंडिकेटर बता दिया उन्होंने, फ्लोरेसीन को बता दिया इन्होंने, इंपॉर्टेंट डाई विद थैलीन ग्रुप है, कंडेंसिंग फैलिक एनहाइड्राइड विद रिसोर्ट्स इन ऑल. ठीक है, फ्लोरेसीन इस जो सॉल्टेड एट वाटर अल्कोहल के अंदर है. फजान्स एंड वॉल्फ रिकमेंडेड 1 to 2 ड्रॉप ऑफ इंडिकेटर. ओके, dichlorofluorocene, no need. Eosine, you must know the structure of this eosine. It is an orange colored powder dye, sparingly soluble in alcohol, bromide, iodide, and thiazide. Even in dilute solution may be titrated accurately, quantitatively react karega. It's not necessary, it is not necessary, it is not required yet. You have the different type of the drug that is used for the quantifier, that is infusion hai ye ka potassium chloride ka, thiamine hydrochloride, sodium chloride infusion, and carbamol. These are the different compounds that contains the chloride ions and can be quantified with the help of these type argentometric type of titration. Okay, go through this one and also go through the lecture that is also provided you, that I provide you. So prepare it for your exam depending upon the all these type of the titration, Mohr, Fajan, and the Volhard, different type of the condition required in all these type of the reactions, limitations, precautions, तमाम चीजें आपने इसको cover करनी है in your notes. Okay, thank you. Allah Hafiz.